So we've seen how to approximate integrals using the midpoint rule. However, one downside of the midpoint rule is that if the function has a lot of curvature, then the midpoint rule might not give that good of an approximation. And so we're going to discuss the trapezoid rule, which will in general give a better approximation than the midpoint rule. So the idea is, as usual, is to subdivide the interval. So let's do that. So we've subdivided their interval, and then instead of approximating using rectangles, we approximate using trapezoids. So we mark off the endpoints along the graph, and then we connect them with line segments. And so now each of these slivers has the shape of a trapezoid. Okay, so we want to approximate the integral from a to b f of x dx should be the sum of the areas of the trapezoids. Okay, so now let's take a trapezoid in the middle as an example. So let's mark this endpoint as x of I. This is x of I minus 1. And the width is delta x. So at the left hand point, the height here is the function value at f sub x minus 1. And then at the right hand point, it's the function value at f of x sub I. Okay, so now the general formula for the area of a trapezoid, with the two legs being a and b and the width being w, is to take the average of the two legs, a plus b over 2, and then times the width. And so for this particular rectangle, this particular trapezoid, so the area of the ith trapezoid, using this formula, so you take the average of the two legs, which would be the function values. So f of x sub I minus 1 plus f of x sub I, take their average, and then times the width, which is delta x. So we'll use this in trying to compute the integral. Okay. So starting from the first one, this would be x sub 0, this would be x sub 1, and so on. So using this formula starting from the first interval, you have f of x0 plus f of x1 over 2 delta x. And then the second interval will be x1 and x2. So f of x1 plus f of x2 over 2 delta x. And then so on. So we continue this pattern. The next one will be x2 and x3, and then x3 and x4, and so on until the last one will be f sub x sub n minus 1 plus f of xn over 2 delta x. Okay, so now all of them have a delta x, so I can factor it out. And then notice how the first one is x0, the second one is x1, but x1 gets repeated twice. And then similarly, all the middle points are repeated twice, except the two endpoints x0 and xn. So you have f of x0 over 2, x1 will appear twice, x2 also appears twice, and so on, until f of x n minus 1 also appearing twice, and then f of xn only appears once, and then this whole thing times delta x. Okay, so now because all the middle ones appear twice, they sum up to be 1 instead of 1/2, and then only the endpoints have the 1/2. So putting it all together, this is 1/2 f of x0. Again, all the middle ones do not have the 1/2. Then xn has a 1/2 times delta x. And then this is the trapezoid rule.